supernova first seen in 1181 is releasing glowing filaments. When a supernova was seen glittering in the night sky for 6 months in 1181, it was so bright that Chinese and Japanese astronomers recorded it as a guest star in the Cassiopeia constellation. Now, astronomers using the Keck Cosmic Web Imager, or KCWI, at the W.M. Keck Observatory in Hawaii have mapped a sphere of strange filaments extending away from where the star exploded. It's the first time the wispy strands, resembling a dandelion flower, have been observed in 3D as they stream away from the blast site around the dead star. The researchers shared the results of their work, which provide new clarity about the structure of the supernova remnant, in a paper published October 24th in the Astrophysical Journal Letters. A standard image of the supernova remnant would be like a static photo of a fireworks display, said study co-author Christopher Martin, professor of physics at the California Institute of Technology and lead for the team that built the imager, in a statement. KCWI gives us something more like a movie since we can measure the motion of the explosion's embers as they streak outward from the central explosion. The finding adds another piece to the puzzle as astronomers seek to understand the remains this unusual supernova left behind. In this case, filaments radiate away from a zombie star the explosion created. And each time researchers observe the supernova, they uncover more surprises. An unusual stellar explosion. The search for visual evidence of the supernova, named SN 1181, went on for centuries before amateur astronomer Dana Patrick first discovered its remains in 2013. Patrick spotted a nebula near the original site of the supernova while sifting through images taken by NASA's now-retired Wide-Field Infrared Survey Explorer mission. Albert Ziegestra, a professor of astrophysics at the University of Manchester in England, later made the connection between the nebula and SN 1181 in 2021. The nebula, a cloud of material ejected from the supernova, was named Pa-30. Then, in 2023, astronomers spied weird filaments glowing with light from sulfur within the nebula. Scientists know the supernova created the filaments, but it's unclear how or when the structures formed. The 1181 supernova was no ordinary stellar explosion. Scientists believe the event resulted from a thermonuclear blast that occurred on a white dwarf or a dense dead star. It's possible that two white dwarf stars collided to create the supernova. The impact, however, only created a partial explosion. The violent outbursts of supernovas typically destroy white dwarfs, but the partial explosion, known as a rare-type black supernova, left behind a zombie star instead. Because this was a failed explosion, it was fainter than normal supernovae, which has been shown to be consistent with the historical records, said Coliad study author Ilaria Caiazzo, assistant professor at the Institute of Science and Technology Austria, in a statement. Mapping the blast site. To take a closer look at the filaments the peculiar explosion left behind, astronomers turned to the Keck Cosmic Web Imager. The instrument is designed to capture information for every pixel in an image across multiple wavelengths of light. The robust data that the instrument captured allowed the team to measure the motions of each filament and create a 3D map. While the filaments moving toward Earth are in the bluer, high-energy part of the visible light that human eyes can see, the filaments moving in the opposite direction appear more red. It's similar to the Doppler effect observed when emergency vehicles turn on their sirens. The horn of an approaching vehicle will emit a higher frequency, but as it moves away, the sound waves stretch out and release a lower frequency. The Keck Cosmic Web Imager enabled measurements of the velocity of any material within the nebula that emits light. When the team analyzed the data, it determined that the filaments are flying away from the supernova site at 2.2 million miles per hour, about 1,000 kilometers per second. We find the material in the filaments is expanding ballistically, said Coliad study author Tim Cunningham, a NASA Hubble Fellow at the Center for Astrophysics, Harvard and Smithsonian, in a statement. This means that the material has not been slowed down nor sped up since the explosion. From the measured velocities, looking back in time, you can pinpoint the explosion to almost exactly the year 1181. Although the light from the supernova first reached Earth on August 6, 1181, the explosion occurred much earlier. The star was 7,500 light-years from Earth, so it took 7,500 years for the bright light from the supernova to be visible in Earth's night sky, said Zijlstra, who was not involved in the new study. Lingering supernova mysteries. The 3D data also pointed to new mysteries, such as a large cavity within the structure of the nebula, as well as evidence that the supernova occurred asymmetrically. The filaments appear to be radiating from an outer shell that extends from the central star, Cunningham said. But the team is still unsure how the filaments formed in the first place. There are two proposed scenarios. One, a shock wave moving back towards the star is sublimating dust into hot gas, which then rapidly cools and coalesces into straight filaments, or two, clumps of dust are being stripped by the fast wind of the central star, Cunningham said in an email. Our observations are not able to distinguish between these two models, and more observations and theory are needed to understand this nebula, but our observations provided an important piece of the puzzle. Studies have been carried out over the past year to shed light on the mysteries of the filaments after a 2023 paper revealed them. While the linear filaments are unusual for a supernova, Zijlstra said they are similar to features seen in planetary nebulas or glowing shells of gas around dying stars, such as the Southern Ring Nebula and Ring Nebula that the James Webb Space Telescope observed. The unique filament structure presented quite a challenge to explain physically, especially given that the observed filaments previously appeared to span from the central to outer regions, said Takatoshi Ko, a doctoral student at the Research Center for the Early Universe at the University of Tokyo. Ko was not involved in the new Keck Cosmic Web Imager observations, but he and his colleagues published a study earlier this year suggesting that the supernova remnant is composed of multiple regions, making it difficult to reconcile the exact composition of the filaments. The observations from the new study show that the filaments only extend across the outer regions of the nebula, rather than from the center outward, Ko said, which adds further evidence to the idea that multiple regions are within the supernova remnant. And the more clarity researchers have about the structure of the filaments, the more likely they are to uncover what formed the cosmic dandelion in the first place.